how everything around us came into existence? This question introduces us to the concept of the Big Bang Theory. The Big Bang Theory is the prevailing scientific explanation of the origin and evolution of the universe. It suggests that approximately 8 billion years ago, all matter and energy in the universe were compressed into an incredibly dense hot state. Suddenly, this state began to expand rapidly, giving rise to the universe as we know it today. Imagine the universe as a rapidly inflating balloon. At a certain point in time, the balloon was so small that it contained all the matter and energy that would eventually form stars, galaxies, planets, and everything else we observe in the cosmos. The expansion of the balloon represents the expansion of space and the spreading out of galaxies in the universe, driven by the force unleashed during the Big Bang. The Big Bang Theory emerged from observations and mathematical models developed by astronomers and physicists in the 20th century. It was supported by evidence such as the cosmic microwave background radiation, which is a faint glow left over from the early universe, and the redshift of galaxies, indicating that they are moving away from each other. An example that illustrates the Big Bang Theory is the discovery of cosmic microwave background radiation by astronomers Arno Penzias and Robert Wilson in 1964. This radiation is considered a remnant of the intense heat and energy released during the initial moments after the Big Bang. Its discovery provided strong evidence supporting the idea that the universe began with a rapid expansion from a hot, dense state. Another example involves the observation of distant galaxies moving away from us in all directions. This phenomenon, known as the Hubble's law, indicates that the universe is expanding uniformly, consistent with the predictions of the Big Bang Theory. Understanding the Big Bang Theory helps us comprehend the vastness and complexity of the universe's origins. It explains how galaxies formed, stars ignited, and planets came into existence over billions of years. Scientists continue to study the universe's evolution using telescopes, particle accelerators, and mathematical models to explore its mysteries and uncover new insights into our cosmic history. In summary, the Big Bang Theory describes the universe's origin as a rapid expansion from a hot, dense state nearly 13.8 billion years ago. By exploring examples and understanding its fundamental principles, we gain a deeper appreciation for how the universe evolved and the ongoing quest to unravel its secrets.
Are you sure your mom's not?
Everyone, welcome to today's school debate, where we tackle one of the biggest questions in science and philosophy. Is the Big Bang Theory the best explanation for the origin of the universe? Let's hear from both sides, those who believe in the Big Bang Theory is the most reliable explanation, and those who question it. Let's begin with the first speaker, A.
It expanded rapidly, and from that expansion, time, matter, and space began. This theory is supported by strong evidence, such as cosmic microwave background radiations and redshift in galaxies, which shows the universe is still expanding today.
The Big Bang isn't just a random guess. Scientists use real observation to support it. The leftover radiation, known as CMB, was discovered in 1965 and is considered a snapshot of the baby universe. Also, the Big Bang explains why we see mostly hydrogen and helium in the universe. The first elements formed. That level of accuracy makes this theory powerful and logical.
We must ask, where did singularity come from? The Big Bang Theory can explain how the universe expanded, but not why it exists in the first place. Philosophers and theologians explain that the universe had to be designed with some purpose. Science cannot fully explain existence.
Big Bang theory is widely accepted, it still has gaps. For example, we don't know exactly what caused the singularity to expand. Some parts of the theory requires unproven concepts like dark matter and dark energy, which we still don't fully understand. So, should we trust a theory that is not completely explained?
Make valid points. The Big Bang Theory offers a strong scientific foundation, but it doesn't answer everything. Like what came before the Big Bang or what caused it. Maybe science and belief can coexist. Maybe the Big Bang was the method and something later was the cause.
Big Bang doesn't answer everything, but it's how science works. It evolves. Just because we don't know yet doesn't mean the theory is wrong. The fact that it supports real, measurable evidence put it above idea based only on beliefs. What if one day the Big Bang Theory is replaced by a new theory? Belief systems have existed for centuries, offering constant answers to big questions. Science is limited by what it can measure. Faith goes beyond.
We can't deny that the Big Bang Theory gives us tools to explore the universe. It helps predict cosmic events and understand galaxy information. Faith may offer comfort, but science offers discovery.
Discovery is great, but let's be cautious. The theory is not perfect. It's based on assumptions that we still can't test directly, like inflation and dark energy. We should remain critical and open to new theories.
And it seems that while the Big Bang Theory is the most accepted scientific explanation, it doesn't answer everything though. Especially the ultimate why. Science offers progress and evidence, while other views offers purpose and meaning. Maybe both have a place in how we view the universe.
Everyone, today's discussion shows us that the origin of the universe is not just a scientific question. It's also a philosophical and personal one. Whether you can lean towards science, faith, or a mix of both. The most important thing is to stay curious and respectful. Until next time, keep questioning and keep learning.
Cold dark cloud of hydrogen gas and dust, known as nebulae. These clouds are held in balance between their inward force of gravity and outward pressure of gas molecules. Eventually, some disturbance overcomes this balance. That disturbance could come from a nearby supernova explosion, or collision with another gas clouds, etc. Then a quiet tug of war begins. The cloud wants to dissipate, but gravity wants to pull it together. Gravity wins, and the material crunches down into a disk. As the gravity pulls more and more gas towards the center, it gets denser, and material at the center begins to heat up. Over the next 500,000 years, the young star gets smaller, brighter, and hotter. When the core temperature climbs to about 15 million degrees Celsius, nuclear fusion begins, releasing massive amounts of energy, igniting the core, and setting off the next and longest stage of star's life, known as its main sequence.
Hey, I was just looking up the sky last night and wondered, how does stars even form? They just don't just pop up in the next instance. Anyway, stars are magic. They're made from huge clouds of gas and dust floating in space. Scientists call these clouds nebula. Nebula? So like they are star North series?
Yes, that's a cute way to put. Imagine a giant cloud bigger than a millions of Earth. Gravity starts pulling all the gas and dust together.
And it gets tighter and tighter. And the middle part heats up. When it's hot enough, a process called nuclear fusion begins. That's when a star is officially born.
So the gas cloud is the baby and the nuclear fusion is the birthday.
Pretty much. And fusion is what makes stars shine. They turn hydrogen into helium, releasing a lot of energy. That's the light we see.
But why do some stars look bigger or smaller than others?
It's because of their mass. Big stars form in the cloud has more material. Small stars from the smaller clouds, their sizes and also change how they live. Bigger stars burn out faster.
Run out of fuel. They don't just disappear. Some become stars like white dwarfs. Some turn into neutron stars. And the really big ones go out with a bang called supernova.
So wow guys, every stars we see in the night sky has its own stories.
Exactly. Fun fact, the elements in our bodies like carbon and oxygen were made inside stars.
So we're literally made of stardust?
Which means in the way that we look at the stars, we're looking at the cosmic relatives.